So today we are going to be working with our inequalities. So if you remember, that's your greater than, less than, greater than or equal to, less than or equal to. So with an inequality, what happens is you have a whole bunch of answers that are your solution. Whereas with our equations, you only had one answer. You'd get x equals 3, and that's the only thing that you have for your answer. With your inequalities, you have a lot of different answers. So for example, if I have x is less than 3, that means 2 is a solution to that inequality. Negative 2 would be a solution to that inequality. What's another one that could be a solution? One. You could have negative 50,000. That's less than 3. So there are an infinite amount of numbers less than 3 that work in that inequality. So let's practice a little bit more. So we have this inequality here. X is less than or equal to 7. They want to know if A, B, and C are solutions to that inequality. So is 9 less than or equal to 7? No. So 9 would not be part of that solution set, as we call it. Is negative 1 less than or equal to 7? Yes. So negative 1 would be part of our solution set. Now for choice C, what does 14 over 2 equal? Would 7 work here? Yes, because it's got the or equal to. So 7 is a part of that solution set. Would 3 have worked in this example up here? No, because it doesn't have the or equal to. So 3 wouldn't have worked in that one. So then they want to know, is the number solution to 2 minus 5x is greater than 13? So let's plug it in. So 2 minus, instead of 5x, it'll be 5 times 3. We're going to see if that's greater than 13. So if they ever give you a number, plug it in, see if it gives you a true inequality. So 5 times 3 gives me a negative 15. 2 minus 15 gives me a negative 13. Is negative 13 greater than 13? No. We put a little line through that because that's not true. And we state no. So 3 doesn't work. Let's try the negative 4. 2 minus 5 times negative 4. We're going to see if that's greater than 13. So what's negative 5 times 4? Isn't that what I said? Oh, my bad. Negative 5 times negative 4 would be positive 20. I was thinking it right. I just said it wrong. So then 2 plus 20. Is 22 greater than 13? Yeah. That one's a yes. So if they give you a solution, they're asking if it's part of the solution set. Plug it in, see if it works. Now a lot of times what they do with our inequalities is they like to graph them on number lines to give you a picture representation of what your solution set is. Because as I said, there's a lot of numbers that could fulfill the inequalities. They want a picture showing us what those numbers would look like. So if you have a greater than or a less than sign, those are going to give you an open circle. So when you're on your number line, like let's say here's my number line, I would have an open circle there for greater than or less than. If it has the or equal to part, though, I would have a closed circle on the number line because it includes that value. Open circle means it's not included. Closed circle means that value is included. And then we also have the not equal to. So if you got an equal sign with a line through it, that means it's not equal to that number. So x is not equal to 5, for example. When reading an inequality, you need to read the variable first and then the symbol. That is key because it's not always going to be in order from left to right. It's not always going to have the variable on the left side. Sometimes the variable is on the right side. So you have to be able to read from wherever the variable is. Now, only when the variable is on the left does the arrow point which way you're going to shade. I don't like to rely on that because the variable is very rarely on the left these days. So if we take a look at our first one, x is greater than or equal to -4. So we're going to practice putting this on our number line. It's greater than or equal to, so it's going to be a closed circle on -4. That's 1, 2, 3, 4. And then x is greater than that. So would I shade to the left or to the right? To the right. Greater than goes this way. On your number line, greater than will always go to the right. Less than will always go to the left. So our second example there, they gave us the inequality graph. They want us to write what the inequality is. So I'm going to start with x. I see an open circle, so that tells me it's not going to have the or equal to. My shading is to the left, so that tells me that it's going to be a less than. So I do x is less than. And then what number is my circle on? 3. So x is less than 3. No, shading's pretty easy on the number line. So we're going to be solving some inequalities, just like we did solving our equations. You follow the same rules. You still distribute first. Combine your like terms. Add or subtract, and then multiply or divide. So your DCV, like we've talked about. And then you always want to check to make sure your answer is correct. Here's an important exception. If you multiply or divide by a negative, you have to flip the inequality symbol. And that's only when you multiply or divide by a negative does the symbol flip. So let's take a look at our first example. We have the linear inequality, 2x plus 3 is greater than 1. They want us to circle each of the values of x that lie in the solution set. So we may have more than one answer. So just like we would for any equation, look first, do we have anything to distribute? Nope. Do we have any like terms to combine? Nope. So now I'm working on getting my variable by itself. So I'm going to subtract my 3 first. So I get 2x is greater than -2. And then what's my last step? Divide by 2. So I get x is greater than -1. So to answer the question, I got to find all of the numbers that are greater than -1. Is -2 greater than -1? No. Is pi? Is 4? How about 4.1? 20? Yes. So B, C, D, and E would all be in the solution set. It's really not, because you've been practicing your equations a lot lately, so it's pretty easy. You want to talk about a lot of work. I had problems that would be the whole front and back of a piece of paper, and that was just one problem. No, it really wasn't that bad, because then you only had to do like 3 of them, so it's a trade-off. Okay, let's take a look at number 2. Which of the following graphs represents the solution set of 16 is greater than negative 3x plus 10? So again, we got to solve for the x first. So I'm going to subtract 10 over. So I have 6 is greater than negative 3x. And then what do we divide by? Yeah, we're going to divide by negative 3. So that means our inequality is going to flip. So 6 divided by negative 3 is negative 2. It now becomes a less than, and then your x. So negative 2 is less than x. So we have to pick the number line that goes with our graph. Does anybody think they found it? It is not B. What kind of circle should we have? Open or closed? Open. So right away, B and C are out of the running. It's D. Remember, you have to be able to read from the variable. This is saying x is greater than negative 2. If you read from where the x is. That's why our shading is to the right. X is greater than negative 2. This one was shading the wrong way. See, that's why I say you got to pay attention. The variable's not always on the left, so you can't always follow the arrow. It's not always right. Okay, third one. Which value of x is in the solution set of the inequality negative 2x plus 6 is greater than 14? So again, solve for x first. So we'll subtract 6. We get a negative 2x is greater than 8. What will we divide by? Negative 2. So therefore, what happens to our inequality? Changes to less than, but it does flip. Yep. So x is less than negative 4. So what's our answer? Is negative 3 less than negative 4? Negative 5 would be less than negative 4. What you have to be careful of is a lot of people rush through this last problem and they go through and they finish solving and they get x is less than negative 4 and then they see negative 4 and they're like, bam, that's my answer. But that's not your answer. You have to make sure you're paying attention to what is there. That one was a less than, so that's why it was negative 5.